Hello everyone, I'm Anbarasu Aladiyan, a lead full stack engineer at Conf42 with more than 17 years of experience in the tech industry. I'm passionate about creating seamless and secure solutions, and my work focuses on key areas like full stack development, cloud technologies, application security, risk analysis, and AI integration. With that, let's get started with the today's topic: automating infrastructure at scale for enhanced developer experience. With the advent of cloud technology, monolithic applications are divided into multiple microservices, each of which runs in multiple instances. Managing such a huge number of instances creates an administrative overhead. Platform teams are struggling to manage increasingly complex cloud native infrastructure while supporting thousands of developers and applications across distributed environments. A recent research across 127 platform engineering teams shows that almost 73% reported difficulties in balancing infrastructure complexity with the developer experience. Traditional manual approach proving inadequate for the modern scale requirements and growing technical debt for quick fix solutions. The impact of infrastructure complexity. We can categorize mainly into three groups. First one is developer productivity, and secondly, operational burden, and finally, business agility. Under developer productivity, developers often spend a valuable time in identifying infrastructure resources and navigating complex systems and platform tools. On an average of almost 4.7 hours per week lost into infrastructure delays, and almost 42% of future delays are attributed to platform bottlenecks. And platform is overwhelmed by manual processes and support tickets. Almost 65% of platform engineers spending on reactive troubleshooting, growing backlog of platform improvements. Slow infrastructure provisioning and scaling directly impacts the time to market. Infrastructure delays contribute towards 38% of longer release cycles and competitive disadvantage in fast-moving markets. Traditional platform approaches cannot scale to meet the demand of modern cloud-native development at enterprise scale. The AI-powered platform engineering opportunity. 58% of faster development is achieved by reducing the deployment cycle time through AI-powered automation and intelligent orchestration. 67% of provisioning speed is achieved by decrease in infrastructure provisioning time with the intelligent resource allocation and predictive scaling. And 71% of system reliability improvement in overall system reliability through predictive maintenance and automated remediation. Analysis of AI-enhanced platform implementation shows remarkable improvements in operational efficiency compared to traditional platform management approaches. AI-driven developer experience transformation. Platform teams implementing AI-powered self-service capabilities report dramatic improvements in developer experience metrics. Almost 64% of reduction in the developer wait times for infrastructure resources and 52% of decrease in support tickets and platform-related questions, and 78% of improvement in developer satisfaction scores across AI implementation. These improvements directly correlate with the increased development velocity and reduced time to market for any new features. Addressing the scalability challenge with the AI. Manual scaling. In initial cloud era, platform engineers manually adjust the resources based on the anticipated needs and often leading to either overprovisioning or performance issues. This approach has the hours of response time and inefficient resource utilization. Let's talk about inefficient resource utilization. When an instance is running with the 0% use of CPU and memory, multiple instances of same surfaces running with a low resource utilization. In this case, all these resources can be reused for any of the services that need additional instances to be spun up. That's about the manual scaling. Let's talk about rule-based automation. This is a very common approach in the current market trend. And this is actually providing basic automation with fixed thresholds and predetermined scaling rules. And it provides very good improvements but lack adaptability. Rule-based approach is resulted in moderate improvement but still requires significant human intervention. Then finally talk about AI for orchestration. This is an advanced approach with intelligent system that can learn from the user's patterns, predict needs, and autonomously optimize infrastructure and very real. AI for orchestration results in minutes instead of spending hours of scaling. thus providing almost 99.9 availability during peak events. Case studies from high growth organizations demonstrate that AI-powered platform engineering team dramatically reduces infrastructure scaling response time while maintaining exceptional reliability. Kubernetes optimization through AI. Kubernetes orchestration enhanced with AI-driven resource management delivers significant operational and cash benefits. We can get intelligent pod placement based on historical performance data, automated node scaling that anticipate workload changes, self-healing capability that reduce mean time to respond by almost 61%, and finally proactive detection of potential cluster level issues. So these are some of the operational improvement that we can achieve. And 43% of better reduction in the utilization, resource utilization across the cluster. And 56% of reduction in the infrastructure cost by maximum resource utilization. And 37% of increase in application performance. And finally, able to handle almost 3 times of workloads on the same hardware. These are some of the business outcomes that we can achieve. AI-powered self-service platform capabilities, intelligence infrastructure provisioning, automated configuration management, adaptive developer portals, proactive security compliance. These are some of the major capabilities of AI-powered self-service platform. We can use the natural language infrastructure requests, which are again translated to properly configure resources with the AI systems that detect any configuration drifts such as and automatically remediate any issues before they impact even the production environments. Personal interfaces that learn from the developer behavior to surface relevant resources, documentations, and optimization suggestions based on project context. And continuous scanning of infrastructure as a code for any security vulnerabilities also. It will provide remediation suggestions. So these capabilities start from the developer experience from frustration to frictionless productivity while maintaining the enterprise grade security and reliability. Recent case study on a global financial services firm, almost supporting 2800 of developers across 340 application streams with a critical ability requirement and very strict regulatory compliance needed. Very big challenge. An AI platform solution was implemented by started with implementing intelligent self-service infrastructure provisioning, followed by deploying AI-based anomaly detection for performance issues, and finally creating automated compliance validation for all the deployments. That resulted in almost 83% reduction in the infrastructure provisioning time and 43% of, almost 47% of decrease in production incidents and over 4 minutes in annual savings for cloud infrastructure cost. Let's talk about implementation. Implementation has 4 phases. First starts with assessment and opportunity identification phase, and foundation building phase, targeted AI implementation phase, and finally scaling optimization phase. How to assess and identify opportunities? Start with evaluate current platform capabilities and bottlenecks, and analyze developer experience pain points, followed by identify high impact automation opportunities. This is something we will actually start with. And finally, define clear success metrics and KPIs. This is to progress. This is to track the progress for the process. And how to build a foundation. Implement comprehensive observability for AI training data. Standardize infrastructure as a core practice. Develop API first approach for all end-to-end services. And create platform team AI capability development plan. And how to implement targeted AI. Start with deploy intelligent resource provisioning capabilities. Then implement predictive scaling for critical workloads. Create AI-powered developer self-service portal. And finally establish feedback loops for continuous improvements. Next, how to scale and optimize. First, extend AI capabilities across all the platform services. Then implement advanced predictive maintenance. Integrate with continuous integration and continuous deployment for intelligent deployment pipelines. And finally, develop organization-specific AI models. This phased approach ensures measurable progress while building the foundation for comprehensive AI-powered platform engineering. Let's talk about what are the common implementation challenges and what are the mitigation strategies. Insufficient quality data for AI training, skills gap in platform engineering team, resistance to automation from operations team, integration complexity with legacy systems, concerns about AI decision transparency. These are some of the common implementation challenges. Let's talk about how we can mitigate these. Begin with enhanced observability implementation. Use synthetic data and simulations while building a real data set. Establish AI education program. Partner with specialized consultants. Use managed AI services as a transaction strategy. Start with human in loop approach. Demonstrate the value through metrics. Create clear scaling pathways. Then create abstraction layers with well-defined APIs. Implement incremental monetization use of AI to generate integration adapters. Implement explainable AI approaches. Maintain comprehensive logging. And create overriding capabilities for any critical systems. Key takeaways. The future of AI is driven platform engineering. Organizations implementing AI platforms see dramatic improvements in developer productivity, operational efficiency, and business agility. Begin with targeted AI capabilities that address the most significant pain point while building the foundation for comprehensive automation. So AI-powered platform engineers are achieving almost 2 to 3 times of better developer productivity and significant lower operational cost. The integration of AI into platform engineering is not just optimization; it's a fundamental shift in how do we deliver and scale infrastructure for the internet. Thank you so much for joining for my session. I truly enjoyed by sharing my insights on AI-driven platform engineering, automating infrastructure at scale for enhanced developer experience. Thank you again for the invitation and for organizing such a well-run event. Thank you.